So that's where we ended off on this one. 4 pi over 3. So anything more than 1 pi is more than 180 degrees, right? If I said 5 pi over 4, you know it's 180 plus more. Okay, so that's what we're trying to picture, is that when you picture pi, you're picturing 180. 4 pi over 3 is more than 3, right? More than a full pi, so then it's a little slice more. Okay, eventually it'll start to, you'll be able to go back and forth between the diagrams. So right now the ratio helps because you can calculate it. I want you to be able to picture it, and then eventually you'll go back and forth between picturing it. We'll keep practicing. This next one is backwards. So if I give you a radian, right, so we're still on 6.1, sorry, still on 6.1, we're in radians, and I want you to convert back. So picture where this is going to be. So can you picture with me where 4 radians is going to be? Is it going to be more than a half circle? 4. Yeah, because how much is this? This should be about 3.14, right? Does that make sense? 3.14 approximately, and it's 4, so it's a little bit more, right? Okay, how much is half of 3.14? Just divide it, 1.57. So if I said it was 1 radian, that would tell you it would be in the first quadrant. If I said it was 2 radians, you would go, oh, it's in the second quadrant. If I say it's 4 radians, it's somewhere in the, how do I know which one it is? Here or here? How much is the full amount? If I go all the way around, that's 3.14. This would be 6.28 approximately. Right, in terms of that's pi, which is about 3.14, that's 2 pi, 6.28. How much is about halfway? If you know this is 1.57, just add 1.57 to 3.14. So where would 4 be? Is 4 more than 3.14 and 1.57? No. So it would definitely be somewhere here. Yes? Can you picture that? So this is where 4 radians is. Okay, let's do the diagrams for these first, and then we'll come back and do the calculation. So where would 5 pi over 6? Pi, they left it as a pi. So sometimes we go right to decimals, because if it's not a nice slice, they have to go to numbers, right? So this is a nice slice. So again, we're going to do this. If it's 5 pi over 6, tell me, is it going to be in quadrant 1, 2, 3, or 4? We know that this is quadrant 1, 2, 3, or 4. Whereas 5 pi over 6 going to be quadrant 1, 2, 3, or 4? 2, right? Because it's 5 slices of the 6. So you know it has to be here. Does that make sense? 5 slices, 5 of the 6. Okay, try 2.53. So again, I just want a quick diagram to know which quadrant. We're going to do cast rule with this. That's why you want to be able to picture which quadrant it's in. Because you'll be like, oh, wait, which one is this one? And then we're going to do cast rule. So we will come back to do cast rule with radians. So same question we did in grade 11, but with radians. So 2.53. So again, I do 3.14. Okay. I know that this is 1.57. I know that 6.28 is 2.53 over here, here. It's going to be in quadrant 2. Does that make sense? 2.53 is between 1.57 and 3.14. So it's got to be somewhere here. Good? There you go. So that's what I want you to be able to picture, is that which quadrant it's in, and then we're going to use that when we get to cast rule in 6.2 in the next section. Okay, so now let's do the conversion and make sure it matches kind of what we're picturing. So to convert this, I do the same idea. So I go x over 4, x over 4, okay, equals, okay, and then now if I do the ratio this way, then I'm going to do, this is radians, so I need you to put pi on the bottom and put 180 here. I don't mind, so it doesn't matter, so I'm going to do or. Some people go, I just do it this way, so 4 over x equals pi, and they always do pi over 180. I don't mind, I don't care which way your ratio sits, as long as, look, the 4 is across from the pi, and then this is across, because you're finding the radian. Does that make sense? You're finding the degrees. So just make sure it matches. So it doesn't matter if it's back upside down, as long as x to the degrees, radians to the radians. Okay, because that's the way a ratio works. Again, just, I know you haven't done it in a while. Okay, so either one is fine, so I don't care. So you can do this or that, up to you. And I'm going to solve this one, so I'm going to bring the 4 up. Bring the 4 up like that, and I'm going to go x equals 4 times 180. Oh, and it says to 1 decimal. Okay, so we're going to see if I have to round it. Will I have to round it? Yes, because I'm not going to leave pi in a degree answer. We just don't. So we're going to go 4 times 180 divided by pi. So 4 times 180 divided by pi, I did this already, and I got approximately 229.2. So I did 4 times 180 and then divided by, and I use the symbol pi. So don't do 3.14. You have to use the whole pi because then it doesn't round to 2 decimal places, right? So I want you to use the pi equals, and then now you round it. We're going to be very careful with our rounding. We don't want to round it twice. So we're going to keep it with the pi symbol. So use the pi button. Okay, so keep that. And then make sure on your answer, I need your units. So I know that sometimes between it you guys lose your units, but on your answer you have to have your units on your answer. Okay, so make sure, and again, we used to have no degree, only degrees, and you said, what else could it be? It could be radians. Okay, so 229. Okay, next one, same idea. You can use the ratio. So this is going to be x to 5 pi over 6 equals 180 to pi. Or this is already put in conversion for you. So an easier way, if it's already got the pi in it, then that means it's already telling you that this is going to be 5 times 180. The conversion is already there. So you don't have to use the ratio because it's already in the question. It's telling you that pi is 180. Okay, so if I do that, 6 into 180 is 30, so that would be 150. Oh, and does that make sense with our diagram? Look, 229, yeah, it's more than 180. 150, yep, it's in the right quadrant. We're good, right? So it matches. So if they give you this, now some people go, but wait, how does that work? How does this work? It works the same way, so I'll show you. So if I said x to 5 pi over 6 equals 180 to pi, look, bring this up, and you go x equals 180 over pi times 5 pi over 6, right? So you multiply up, division becomes multiplication. Look what happens. 5 times 180 is 1. So it's just you're doing the same work, right? So some people go, wait, how does that work that you didn't use the ratio? Because when you bring this up, the pi's cancel out, and you're left with 5 over 6 times 180. Okay, so it does work. The ratio that we just did here, the same formula as this one, but it's just faster. If pi is there, you can just put 180 in. Okay, either one works. It's just that this is way faster. You'll get used to it. You'll be like, okay, this is where I can put the 180 in. There, good. All right, so that's, again, as an aside. So or, should I put that down as an or? I'll put it down. So or, you could have converted it, just so you have it in your notes. You could do x over 5 pi over 6 equals 180 over pi. You bring this up, and then you get x equals 180 over pi times 5 pi over 6, and then that was the same thing. Same. Okay, so it works the same way. All right, last one. One more conversion. Is this okay? Too fast? And then so we're going to go x to 2.53 equals, and we're doing, this is radian, so pi and 180, and then I'm going to bring that up here. Now, when I get this, I got approximately, what do I get?
145?
Yep, but that's why I asked it. So this one becomes 150 exact, right? So this is why I want to point this out. So this is exact. Does that make sense? There was no decimal place. So the question says to 1 decimal. If you get an exact answer, don't put a decimal to it. It's 150 precisely. Does that make sense? So don't put a 0.0. This becomes how much? 145 point, right? I get 180 times 2.53 divided by pi. I purposely chose this one. I get 144.9583232, right? So when you round it, this becomes 0, and it becomes 145. But you cannot put that, because that's like saying that it's exact. Does that make sense? This, you rounded it to 145, right? And I don't want you losing these little half marks, but you will, right? So if it's exact, this one you rounded it, so I still want the 0 there, because I said to round it to 1 decimal place. So here, I need you to keep this, because this is rounded. This is why I purposely did these two beside each other. Okay, this one here is exact. Don't put a decimal, because there wasn't a decimal. It's precisely 150 with nothing. This is 145 with an extra 0 because I rounded it to 145. And because I said 1 decimal. If I said to the nearest, then it'd be fine. Right? But I said 1 decimal. Don't drop the decimal of 0 because it was rounded. This one, there is no decimal, because we say round if necessary. This is not necessary. It's precise. Exactly. Nothing left. This one, you have to put the 0. Right? People go, it's the same number. You're saying 2 different things, though. Okay, so see the difference between them? Right, so no half marks off. That's why I purposely made this one up so it was the same as this, but not the same, right? Okay, that's it. Last one here. Any other questions? Okay, so this last one here, now read the question with me. This is the random question where you should recognize. Determine the measure of the central angle, and you're like, okay, angle, that's kind of like what we're doing, that's formed by a arc length. It's the only question that asks this. It's really the only thing we can ask. With a radius of. This is the question where I need you to know that random little ratio formula that we have, and it's going to just come up once in a very blue moon, but it's going to be this. I need you to know theta equals A over R. That's it. This is that question. It's the ratio of the arc length to the radius. It's the only time it'll come up, but you have to know it. Sometimes we ask it, sometimes we don't. Who knows? But just make sure you know it. Okay? Again, this is arc length. That's radius length, and this is in radians. So I'm going to note that down. So one more time. This has to be in radians. Okay? And this is arc, and this is radius. Oh, sorry. Okay, and again, you don't have to have this, but just for yourself. Okay, and we're going to take this. So this is, I'm just going to put this on the side. Whoosh, 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 for you to remember. And then we're going to answer it. So then I know theta. So express in both degrees and radians, determine the measure of the central angle. This is the central angle. It's going to be A over R. Please give the formula. Yes, I do want the formula there. Then you're going to sub in the A, which is 10. The radius is 7.5. I chose this on purpose because it's funny. You guys forget your old stuff. If you have a decimal on a fraction, and I said to keep everything, I didn't say anything about rounding it. So you want to keep this exact as much as possible, whenever possible. You're allowed to multiply the top and the bottom by 10. Again, we've forgotten all of our fraction stuff. We usually head for the calculator. If you multiply top and bottom by 10, just a little trick, because sometimes it comes in handy. That's going to be 100 over 75. Now you can reduce it. So divide the top and the bottom by 25, and it's 4 over 3. Okay, you are allowed to do that. It's a fraction, right? So again, right, this is something you're allowed to do whenever you get a decimal in a fraction. We don't usually get a decimal in a fraction, right? But if you do, you're allowed to multiply top and bottom by that. So that is this, and this is in radians. Right, that's my radians. Okay, I ask you to convert it, so it's got a double question here. So convert to degrees. Okay, so I want to convert to degrees, and we know how to convert it. We just did that in the questions of before. So we're going to do x to 4 over 3, which is going to be degrees to pi. Right? And we just did this, so bring this up. Now, this one I'm going to have to round because we're not leaving pi in my answer for degrees. Do not leave a pi in my answer for degrees. It's just weird. And then we're going to bring that up. So we're going to multiply both sides by 4 over 3. So I got approximately 76.4 degrees. Okay, so 4 over 3 radians is 76.4 degrees. Does that make sense? 4 over 3 is 1.33. 1.3, when you think about it, is in the first quadrant, which is where 76 degrees is. Again, you can't, I know it's not comfortable at the beginning. Okay, it'll get more comfortable as you picture it more. Okay, backwards question, because you're like, okay, is that the only question we can ask? We can ask you backwards things. So determine the arc length, right? So this is the only question with arc length and radius. Right, and you go, oh, arc length radius, I know what that is. That is this question. So theta equals A over R. I have the arc length. Oh, no, I'm looking for the arc length. I have the radius. So I'm looking for A. I have the radius. What am I missing? Central angle. Can I put the 59 here? So you can put the 59 here? No! No! Cannot. Go back to what I just said up here. This central angle has to be in radians. I just taught you how to convert to radians. What a coincidence. So I need you to first step 1, you don't have to write that, but convert to radians. Okay, I need you to convert to radians first. So it's going to be x to 59, equals 59 equals, this is 180 to pi. That will get me, now, whenever possible, try to keep 4 decimal places when we're dealing with radians. So 4 decimal places. If it doesn't tell me, and then I'll round at the end, but try to keep more. Think about it this way. I just converted. We just converted. Pi is 3.14 equals 180 degrees. So 3.14 now is 180 degrees. Every decimal counts, right? 3.14 is now 180 degrees. So rounding it to the nearest radian means that we've rounded it to the nearest 100th degree. Right? So we're going to bring this up and going to do x is going to be approximately, I got, what'd you get? What'd you get? So we're going pi divided by 180 equals times 59. I'm going to do 1.0297. Let's keep 4. Okay, let's keep 4. That's my radians. And then we're going to sub that in here. Okay, because remember, radians, every decimal counts. Frequently, we keep 4 decimal places. It was always my habit, and we're always told to keep 4, because 1 decimal place is a lot in radians compared to what it was in degrees. 180 degrees is 3.14 now. So we were always told to keep 4, so we're going to go 1.0297, and then just bring the 7.5 up, and I got times. So 1.0297 times 7.5, and I get 7 point, and then for the actual arc length, I'll round it to 7.7 is approximately, so therefore arc length is 7.7 centimeters. And you keep the same units as whatever was in the other, right? So if it's arc length to radius, if the radius is in centimeters, your arc length is in centimeters. All right, deep breath, let your brain absorb our new found units, and that's it. Yes?